This is a few concepts that I've been wondering. There were a lot of assumptions made inside of a lot of the books on stellar interiors and stellar dynamics and properties of stars, and I couldn't quite put my finger on what I was seeing and what they were doing wrong, but I think I finally figured it out. I think it amounts to the question, is the sun isolated, closed, or open thermodynamically, meaning heat and energy? I think I spelled that wrong. Now, a lot of the equations of state for stellar interiors and structure, what they do is they obsess over the core, or the supposed core of a star, the nuclear core, hypothetically speaking, theoretically speaking. After all, it's only a hypothesis of how the sun actually works. And by doing that, they look at the core, and the radiative zone becomes the central regions of the star. Okay? Here's where all the sun radiates. There's a sun inside the sun. We had Occam's razor for that with the previous video. But in other words, to make their equations work, they only look at the nuclear core. They only look at this. And they assume it is an isolated system. And matter and energy don't really pass that boundary right there. So no matter escapes and no energy really escapes. It goes back into the star again. The whole mathematical formulas only account for this area. That's why they call it a star that's in local thermodynamic equilibrium, or LTE. When they say the star is an LTE, they're not referring to the star surroundings at all. They're only referring to the equations for the interior of the hypothetical star that they supposedly are studying. That being said, you have your closed system. Now, a closed system would be a little bit more correct because energy can enter into the sun at will and energy can exit the sun at will. But for a thermodynamically closed system, matter cannot escape the star, meaning it keeps its mass as it evolves. I don't think that's correct either. I think what's really happening with the sun is that it's an open system. Energy can enter the star in the form of meteorites falling into it, kinetic energy, and then energy exits the star as radiation. As well, matter can enter the star in the form of meteorites, and matter can exit the star in the form of CMEs, solar flaring, and solar wind. Meaning, the open system means matter is exchanged in the system over its boundaries to the surroundings, and energy is exchanged in the system with the star in reference to its surroundings through the boundary. Now, a lot of the interior stellar equations that you read have to deal with the sun being something more like this, and then it's a mix of this as well, being closed and isolated, because they don't really care about what's happening out here. When they try to figure out how the sun works, they say, oh, to hell with that. We don't actually care that the sun's shining. That's very, very bad, because if you have an equation that ignores the fact that the sun is shining and releasing energy and matter into its surroundings, then the equations don't account for the fact that the star is evolving. That means this is very, very, very bad. And the majority of the stellar equations that you try to figure out and rack your brain over are absolutely false in every way. You'd just be wasting your time trying to make sense of them. As well, we know that solar wind exits the sun, so they're not closed systems either. the only equations that are going to work are the open equations, where the sun is far removed from both LTE and, well, local thermodynamic equilibrium and thermal equilibrium in general. Sorry, I scribbled that. Thermal equilibrium. Far removed from thermal equilibrium. Meaning, as it evolves, it's trying to get to be a thermally in equilibrium with its environment. Has to do with the zeroth law. What it's literally trying to do is, okay, say the sun is 6,000 degrees at the surface, and you have it rockets up to 2 million in the corona, and then outer space is what, like around 4 or 3 degrees Kelvin. It's literally trying to rocket out all that heat away from the surface, meaning it's starting to cool, it's cooling down. That's why it's radiating. So, yeah, there's that. So, when just as a reminder, when you look at a lot of the equations of state, try to ignore them, because they don't look at the sun as being in an environment. They look at it as being in a giant box. And as well, they even look at it in a giant transparent box, like a big glass box. You know, a glass box meaning light would be able to radiate out, but no matter would leave. So the surrealistic notions of this, as the sun is not losing any mass as it evolves, expanding into a red giant, and then ripping away its outer envelopes to become a white dwarf, and it has all this strange stuff to it. The truth is that stellar evolution is quite mundane. It's very boring. The sun is on its way to becoming an orange dwarf star, which then will shrink considerably more as it loses energy and matter, becoming a red dwarf star, and that red dwarf star will become a brown dwarf, and on and on and on a giant continuum. I think Mr. Anthony Abruzzo would agree. I think Lord Kelvin would agree. I think, let's see, who else would agree on that? Oh yeah, Alexander Oprin would have agreed. Let's just consider this case closed.